Superposition theorem statement. Superposition theorem states that in any linear complex network having several sources, the response on a particular element can be determined as the algebraic sum of the responses caused by the individual sources acting alone, while the other sources are non-operative. The term response refers to the current or the voltage of the element, not the power. While considering the effect of individual sources, other sources must be non-operative, such that they are replaced by their internal resistance. If the sources are ideal, they are replaced by a short circuit or open circuit for voltage source for and current source respectively. And if the sources are non-ideal, they are replaced by their internal resistance. Example: considering the given circuit and find the current through 2 ohms resistor using superposition theorem. Step 1. At first, find the current through 2 ohms resistor with 48 volts source acting alone, hence replace the 24 volt source by a short circuit. Let's see the diagram. The 24 volts was short circuit. Here current I2 flows through the load resistor. Hence current I2 flows through the load resistor. To find the load current, find the total current supplied by the source with its total resistance. Then apply current division rule and find the current through 2 ohms resistor with 48 volt source acting alone. Calculation for the steps: for R equivalent 4 plus 8 into 2, by solving we get R equivalent equals to 5.6. For this one, current equals to 8.57 amperes. Current for 2 ohms resistors by using 48 volts battery equals to 8.57 into 8 by 8 plus 2. By solving this we get current equals to 6.86 amperes. So the current supplied by the 48 volts source is 6.86 amperes. Step 3. Now consider the 24 volt source alone and replace 48 volt source by a short circuit. Now find the totals. Check the diagram. 48 volt source will be short circuit. Now find the total resistance of the circuit and by find the total current supplied by the source. Then apply current division rule at node A and by find the current through 2 ohms resistor while 24 volt source acting alone. R equivalent equals to 9.33 ohms. For this, current equals to 24 by 9.33. We get current I equals to 2.57 amperes. Current by using 24 volt source equals to 2.57 into 4 by 4 plus 2. By solving this we get current for 2 ohms by using 24 volt source equals to 1.71 amperes. Here the current supplied by the 24 volt source is 1.71 amperes. Here step 4. Finally add the two currents considering their direction. Here the two currents are flowing into the 2 ohms resistor with the same direction. So the total currents flowing through 2 ohms will be the algebraic sum of current at 2 ohms and current at 2 ohms by using 24 volts and 48 volts source. Current at 2 ohms equals to 48 volt source plus 24 volts current, 6.86 plus 1.71. Total current equals to 8.57 amperes.